Okay, well, I missed the beginning of this lesson too on recording, but we're editing more of the control system box to attempt to get the part into here. Okay, while Nick's finishing up his version, I'm going to go ahead and maybe I'm going to make mine caught up so we can basically redo the same thing. So we're adding a new sketch on the bottom down here, and we're just going to draw a box that's going to sit somewhere down here. So we can you can use our snap feature, but we don't want to actually snap it in the corner. So we're just going to use this dotted line to kind of give us a location for this rectangle. Do the same thing over on this side. So now those sides can't be moved because they're already black. So they are coincident to this line and to this point. So they're going to stay there. And then we can change the dimension however we want. So I can go through and I can use D for dimension. I can add it out here as thickness because I've already set that up. And then we can adjust this one too to 0.25. All right, and then just like Nick already did, we're going to extrude this. We're going to extrude this sketch. We're going to tell it to be new, so it's a new part. We're going to flip the direction so that it's going up into the part. And we're going to make it 5.5 inches. All right. I think, does that look about the same? Oh yeah, it just says that cut out. Okay. Yeah, so from there to there is 5.5. Okay. And then from, let's see what we're looking at. The other dimensions that Nick was just working on are these rectangles. So when we click, we can see that this is 1.75 down, so 1.75 inches down from the top and bottom. And across the side, we're going to go all the way from this edge, because that's where the piece actually stops. And we're going to go to that edge. So we're going to do 1.025. We're going to call it an inch. I don't really know where some of like these smaller numbers are coming from. This may just be some of how Felipe assembled it. But I don't think there's any reason to leave off a 0.025 under a 64th of an inch. I don't think it's necessary. Okay. So, or under a 32nd, sorry. All right, so what did I say my numbers were? 1.75 and 1. So we're going to draw those in a new sketch. The N button makes us normal to, which basically makes us flat to whatever we're sketching on. So now we can draw in here again. This is from the true corner, so I can just draw this out. Once you click a shape, you can just start typing, and it kind of highlights which one it'll dimension for you. So it's going to dimension my width first, so I can do inch, and then I can do 1.75 inches. I have that drawn over in the true corner because we're taking out all of it from this whole part. And then there are multiple options for how I can get the same thing drawn on this side. The option that Nick was suggesting earlier is we could just use a mirror. So I can go through and I can draw a line down the middle. I can use the mirror tool here. It asks me to select.
I have a question.
Yeah, what's
Whenever you click a key,
it as the mirror line, and then you can select the parts you want to mirror. So I could mirror all of those, and it just does it for us. So now we have that mirrored rectangle. So that's one way to do it. Another way to do it is to we can just draw that other rectangle, right? So I can just come over here to the corner. I can draw a rectangle. I could type the dimensions again if I wanted. So I could type 1 in 175, but then if I wanted to change them, I'd have to edit them both. That makes it a little more annoying. So instead of that, I can just hit escape and not have any dimensions on it. And I can use sketch constraints. So I can click on like these two top lines because we know we want these to be equal. So I could either come up to our little drop down menu for our different constraints and select equal, Or like I'll do for this one, I can click the two side dimensions and I can just hit the E button on the keyboard and it'll set it equals for me. So now without having to do a mirror, I can make those, and it's probably a little faster to do it that way compared to the mirror. If I was doing multiple features, so if I had other holes or something that I also needed to do, I would probably use the mirror tool. If it's just a single box, it's kind of up to you. And to remove them, we're going to use the same extrude button that we used to create the other part. But instead of new or add, we're going to use remove. And remove is basically how you cut things out. We're going to switch this from blind. We're going to, like, it's fine if you do that. Like, you can just extrude an inch and it'll cut it away. It's going to result in basically the same part here. But in general, I like to get in the habit of swapping this to up to next on most of my cuts because it'll automatically kind of cut the depth of like to the next face of the part. So if you're just trying to put a hole through however thick your part is, up to next is super handy. It's just a little bit cleaner than through some dimension because every once in a while if you have a part that's bigger and it's built a different way, maybe you're going through like the side of a tube or something, you may not want to go all the way through. And up to next is just a handy way to make sure we're doing that. And then you have to select your merge scope, which is basically which part do we want to cut out. So we only want to cut out from this bottom plate. We're not trying to worry about any of these others. So we're going to click down here. The preview comes out correct. It shows that we're removing the bit of the part that we actually want to remove. And then I can click check and we have that part removed. So now we're looking pretty close to how this looks, but one of the big differences here is this overlap, right? We have this whole part coming through here. That's definitely not what we want. So to avoid that, or to change that, we're going to use our feature script called laser joint. And so I'm going to go over that again for people who haven't been here for the other box tutorials. But basically, laser joint lets us create those finger slots really easily. And we have our settings basically saved from our previous ones that we already did, which works well. We have to select our tab and base. So we have to figure out which one is basically going to be put into each piece. The way this was catted, this back plane or bottom plane, whatever you want to call it, is basically the tab in all of them. So it has the three little parts here, it has the three little parts here, and it has the three little parts on this side. So it's the tab in all of them, and the base is the other part each time. So we can click here, and then base part down here, and it kind of gives us a similar pattern to what we had in the other document. Go ahead and hit check. And I can grab laser joint again.
What are the dimensions of the? I mean, were those?
Okay, so yeah, once we have those first three fingers done on that side, we can do the same thing again with laser joint. All the settings are already set for us. We can just tab those in and see what it looks like. It did not like that. So because this is shorter, it doesn't like our pin width being an inch. So we have to make those smaller, similar to how they're smaller on here. And we can kind of choose what those look like. Half inch is probably pretty good.
Yeah, Alan, what did you say about the merge scope? I didn't.
Oh, so we're just so you're just clicking whatever part you want to get cut out of.
Oh, okay.
Yeah, so in this case, you just want to click that bottom part. Yep. But so your sketch, though, if you look at it, if you zoom out a little bit, you're missing, I think, the corner of your part. So you didn't cut out that side over there.
Yeah.
So we need to go and change that sketch to where you're cutting out the full side of the part. All right, so that looks fine for what we're doing. We have those three little tabs, and then we can, I believe, no, maybe not. And then we'll just do it again in the same way we did, tab and base, and we kind of get that same geometry over on the right side of the box. All right.
I find the laser joint thing. Feature script is somewhere.
Here, if you don't have the laser joint trigger strip, let me put this in the Discord real fast too.
I mean, I have Julia's feature scripts.
Okay, you may not have laser joint though. We added that one afterwards. It's not in Julia's.
Oh, okay. Well,
It's in the chat now, so you can add it the same way as you did before.
okay.
Okay, so yeah, so Nick, you don't need to
Mhm.
draw your rectangle. You don't have to draw around that part. You can just draw completely over it. Right?
Oh,
Like,
okay.
even though it's like you see that part, it doesn't have to be there. So you could just draw the rectangle and it'll just cut it away anyway.
Oh, okay.
So, Alan, how are you removing the rectangles that you made?
How are we removing the rectangles? All right.
How are you removing them from the? Yeah, sorry.
Yeah, no, we're back. I have no problem backing up. That totally works. Okay. So, let me back up to here. So yeah, so we have them sketched, and I just have them sketched in the same way. Like it's just a full box. So what? Yeah, because we don't want. Because what would have happened if Nick, had you done yours where you have like this kind of cut out and you left this here, you'd have a bit of the part here, and then when you went to do laser joint, it would think this was still part of this panel, and it would get a little awkward.
I mean,
So we definitely, yeah. So drawing this out is definitely the way to go. So we have those sketched, and then the extrude we're gonna do is we're gonna extrude and we're gonna switch it from either new or add or whatever it defaults to, and we're gonna switch it to remove, because that's how we actually cut things out. And then we're gonna swap this to up to next, because up to next gives us just the cutout for the thickness of this plate, which is what we want here.
The dimensions of the rectangle were 1 by 1.75, right?
That's what I used. Yep. So yeah, so 1 wide, 1.75 tall.
So when I'm trying to remove, no merge scope selected.
Oh right, yeah. So you have to select the merge scope. So it'll default to here, and there's no merge scope, and your removes will be red, and it doesn't really know what you're asking for yet. So you have to tell it which part do you want to cut out, right? Because I could tell it I want to cut out this part, and it's gonna only try to remove that little bit of material that's inside of there, right? But that's not what we want. So we're going to tell it the merge scope is this bottom plate, and then it's going to remove the part we actually want.
Got it.
Yeah, so merge scope is always like, it's always just asking, hey, since we have 4 parts drawn in this part studio, merge scope is just being like, hey, you're cutting something or adding something, like what part am I actually working on right now? Because it doesn't always know. So yeah, so we can just check mark that, and then we can go through and, like you said, do the same laser joint that we normally had. This one is the same settings as the other 3, so they all look the same. And then the next 2, I just made the width of the pin 1/2 inch so that there was enough room for a couple bolts in there. We could change, if we wanted to, we could change like the offset maybe. Maybe this is only a 1/4 inch instead of a 1/2 inch if we wanted to add a little bit of room for our bolts here. I don't think it matters that much for this design. It could probably work either way. But it is something we might change in the future. But one of the nice things is it's pretty quick to do that, and it shouldn't affect too much of our other work, hopefully. That's not that one. Okay, so kind of the rest of this project, there's a plate that's a little bit harder to see. We have this plate right here. So I'm actually gonna hide some parts above it if I can do this cleanly. Let's see. I want to grab. No, I want to grab. Let's see. Sure. And then we're just going to hide. Well, that mostly worked. We got not all of the PDP hidden, so let me hide the rest of it. There we go. So I was looking for what the rest of this board was going to look like. So yeah, so how did we do this? Okay, so this panel is slotted. I'm trying to figure out what Felipe did for part of this design. Why are those missing? Okay, that's the Robo Rio base.
Okay.
That's the
For
bottom.
some reason, I have 4 pins.
So on the bottom of the panel, it's T-slot jointed to the sides.
Yeah, the bottom is T-slotted to all 3 panels that it's overlapping.
Okay.
Because yeah, so the way we would construct this is you'd put these 3 together and then you'd like slide the back on all at one piece, right? You can imagine you would just like push that on and bolt it into place. This one, oh, that's right. It's like this weird part on the bottom of this thing. This has this like angled bit that I forgot about. What I don't understand at the moment is why this isn't T-slotted to here. And I have no idea why it's not. Oh, I don't think we wanted to have the nuts coming up into this board is my guess. Because any place where we have these cross nuts, we'd have to have the, you couldn't have a PDP sitting flat. So I think that's why we did that with the plan that it's basically just held on here. It's held up here with zip ties and here with zip ties. That's not too bad.
How
Interesting.
I created a laser joint, but it has 4 pins.
Okay, so yeah, so in the laser joint settings, if you have a 4-pin laser joint and you only want 3, you can come down here and you can do number of pins and you can swap it to 3.
Yeah, the thing is that I have number of pins set to 3, yet there were just 4. Now I unchecked something and now there is only 1.
So yeah, so you want to, so basically it needs to basically kind of look like these selections, and you also need to make sure you selected the right object for which like direction as well. So this back thing has to be the tab part, and the base part has to be down here. You also need to make sure that you're in single and not automatic.
So wait, is it supposed to, are we laser joining it or are we T-slotting?
Laser joint still.
Oh, okay.
Yeah, so T-slot is once you're actually ready to put like the nut slots in, when you actually want to do this. Laser joint is when we're just making the little finger and tabs.
Yeah, okay. Now my tabs worked, but I have another question. Like when you're doing something like that, I think it was like updating very slowly. I would change a setting and like it wouldn't change for like it wouldn't change on the actual CAD for like a minute. And
Some of that does depend. Some of it may depend on your computer. Most of that is OnShape, so it kind of depends on what we're looking at. It shouldn't be that slow. As long as you hit tab, like if you hit tab, like I can change the pin width and I can hit tab and it does it pretty instantly for me. Some of it is internet connection speed because you are pulling it from the server. So it is somewhat dependent on what your specific house setup is.
although actually no, it was pretty fast now.
Yeah, it also just maybe
yeah,
maybe the first time you ran laser joint in that session or something, I had to load the feature script because it's a lot of it does get cached and things too, so it depends sometimes.
Yeah, I might have also done something that like I might have just made an error and it got confused.
That is that is something that would happen in OnShape sometimes where it doesn't render it if there's something that doesn't if somehow you type something where it doesn't think it'll work, it won't change anything or it won't render it properly until you kind of fix it. Okay, so for now we're not going to change the design. I'm questioning some of what we've done down here, but I don't really have a fix for it yet, so we're just going to keep going off this design, and then once we have it fully catted in OnShape, we can worry about changing things.
So do you want to make those handles next? Not the top handles, but like that one. Yeah.
So I think we have to make this plate first, right?
Oh yeah, okay.
Yeah, so that's kind of where I was at. So this plate, we'll ignore a lot of the holes that are inside of it because those will get added later. So we just need to draw the plate overlapping these two side plates so we can do the laser joints again. But to do that, we have to figure out where we're drawing it, right? We need some place to draw it, and this is basically in midair, right? We're basically drawing it somewhere in midair up over here somewhere.
I think we could like draw it from the bottom plate up.
Sort of. So we basically want to create a plane for us to sketch on. So we're gonna figure out the distance from this plate to this plate. So it's 3.25 inches. It tells me down here in the corner. And so I know that I'm 3¼ inches above this bottom plate. So we're gonna make a plane and make it 3¼ inches above. So we have this plane button. I can click here. It's already set to offset, which is perfect. That's what we want. We're going to offset it 3.25 inches. And it kind of previews our plane 3 is what it's called. Oh no, plane 1. And we are ready to go. We can change like the name of it if we want. So I'm going to put it as like PDP plane or something. And now we have it named, which is also convenient. We haven't named, I forgot to rename this bottom part after we named it, or we made it, so I'm going to name this.
It's 3.25 inches from offset from the blue place, right?
3.25 offset from from where that top of that side, yep.
That is weird. On mine, it's not doing.
Mine's
still flat.
Or it's a lot shorter than.
Yours, for some reason, aren't in inches, so type inches. I believe you're in centimeters. There you go.
Oh, there it is on mine.
Somewhere you may have to change your default unit to inches, because I think it might have been in centimeters.
Yeah. Okay.
Yeah, if things are just really short for some reason, assume about that ratio short. It's probably because you're in centimeters and not inches. And then once we have that sketch or that plane ready, we can go ahead and make a sketch on it in the same way we make sketches on anything else. We just click the sketch button, click on the surface we want to sketch on, or the plane we want to sketch on in this case, and then we're ready to get to drawing. In similar ways we did before, we have to figure out which part is actually laser jointed. So it's only these side panels. So this panel is going to basically touch this bottom panel but not overlap it. But the side panels, it's going to actually overlap so that the laser joint feature script can do its thing. So we are, how big are we? We're top to, maybe it's being weird. No, bottom. There we go. So 7¾ long, and we know the width because we know it overlaps these side panels. So I can go ahead and draw that. It's just a rectangle again. I know it's going to be, we'll put it on that edge in a second, because it doesn't seem to like coming up that high. All right. So I have my rectangle. I'm just going to set this height, which we just measured, to 7.3 or 7.5, 7¾ And then I'm going to start constraining some other things. So I'm going to click on this line, I'm going to click on that line, and I'm going to make it coincident. I'm going to click on this line and that line. I'm going to do the same thing. I'm going to do it one more time over on this side. Or I'm going to fail at clicking things. There we go. All right. So now we have our same box again. That lined up right at about the handles.
How did you create that sketch that is up there?
Yeah, so that was where we made the plane. So let me track a little bit. Yeah, so we're just gonna use the plane tool.
Yeah, plane tool.
Plane offset, and it's 3 1/4 above this top part, and then you just sketch on top of the plane. Yeah, creating planes is very, very helpful anytime we need to make something a certain distance away from anything else.
And the offset is how many inches?
3.25 inches. Okay. Yeah, so then to extrude this, because this is going to be that panel thickness, we're going to use the variable that we already created, thickness. So if we need to go through and edit this, we can later, and all the sizes of the material will change. We'll look at it and make sure we actually sketched what we want. It's overlapping both of these side panels that are going to get laser joints, and it's not overlapping the bottom one, which is perfect for us. And it's going the correct direction. So when we measured inside of here, we measured from the bottom of this to the top of this, and we got 3.25. So that's what we want here. So this plane was 3.25, so we want to make sure our extrusion is going away from this bottom panel. Otherwise, we'd lose some space down there, and it wouldn't work the same. So I'm going to go ahead and hit check, and we should have our new part. We can double check. For some people, it may not have defaulted. It may not have defaulted to a new part, so make sure we're selected new here. If for some reason you select add, you could do something a little weird, and you could add it to like one of the side panels or something. So we want to make sure we're on new.
Go on.
And then we have this overlap where we get kind of the weird gradients of the different colors.
Yeah, I think that's called Z fighting.
Yeah, so then once we have that, that's basically the sign in all of our, anytime we're designing something like this, that we need to use laser joint, because that's how we're designing it. Otherwise, we clearly couldn't actually manufacture this. We can't have them overlapping. So laser joints are friend. We check which one is the tab and which one is the base again. And this inner part's the tab for both of these side parts. So we do that same thing. We just do tab and base. It swapped for me back to kind of our default 1 inch pin width and 1/2 inch offset distance. I'm totally fine with that. I think that's going to work out okay. It's going to make everything look kind of symmetrical, or at least semi. It doesn't line up everything perfectly. Like these pins and slots aren't perfectly lined up. If we really wanted them to be, we probably could do that. There's no real reason for it to be. So I think leaving them like that is totally fine for us. And then we would just do another laser joint and do the exact same thing. So all it is just a couple clicks, and it makes our part the way we want to. We have this plane that we don't need, so we can hide it, because we no longer need that. And then whenever we make a part, we should try to rename it whenever we can. So this is the plate that that device called the PDP is going to mount on, so we're just calling it the PDP plate. I don't know why it didn't show all, oh, because I had hid some earlier. Confusing. Okay, let me.
Yeah, I created some laser joints.
Alan, how did you make the laser joint have some clearance on the side? Because mine is evenly spacing it to where it's like hits the side of it and it won't connect. So how, like, where the pins have space between where it is and like the side of the part.
That edge offset checkbox
Mm-hmm.
with either 1/2 inch or 1/2 inch is about right. I think that's what we've been using most places.
Okay, I see it.
And that locks in your little, yeah. So it makes it so it'll actually slot all the way in and not just like connect kind of weirdly. Yeah, because almost always we like designing closed joints. Like you could design them to where they're open, where like these two faces kind of mesh, and you could put them in at like a corner. But that makes it a lot harder to do the bolt and nut connection that we prefer to do. Yeah, this is definitely these closed joints where you have like a box for the finger to go into instead of just a U. It gives a much stronger joint in the final product. Okay, so we have all but 3 parts at least like mocked up now. So we need these top 3 parts. With this one definitely being sort of the most intricate, is it has this little like ramp down function down here.
Is that so like you can like detach the
So
handles, like
what
the
it's
size ones here?
for, if I can bring in section view real fast. All right. So what it's supposed to be for, but I don't actually know how well it worked, is it's supposed to be to keep the battery off this back wall. But I don't know how far we actually got into that and how much it worked. But yeah, the basic thought was we don't want the battery hitting any of like, there's going to be like zip ties on this wall and some other things. And we wanted to be able to keep the battery fully secured. So I think that's what this ramp design was for. I don't remember how far we got into. We've never tested it, so I know we haven't like, this is almost certainly not the final angle or anything. Like that would all have to be tested. But that was some of the thought process with how that would work.
Oh, why don't you just do kind of an L?
I'm not understanding your suggestion. Kind of an L, but because I mean, so in this case, we want the battery to like hit here and like smoothly come down into this gap. Is the plan?
Oh, okay.
That was the original plan. Again, we don't know if it actually would work.
Okay, that makes sense. I was thinking of a completely different thing that um I would have explained, but now that I know that it's like a ramp, so the battery comes down and fits snugly in there.
Yeah, that was the original plan. There's some issues where like this will have a nut in here that kind of protrudes up, and we don't really want the battery resting on these nuts. So I think there was some plan to put like a rubber floor down, maybe. I have to look at. Yeah, we may have to consult with Felipe to see if he remembers what our plan was for down here. But or we can just come up with a different plan at some point. We could have a part that the battery sits on. We could extend these further and have the battery sit on more of this area or something, which could work. It just kind of depends on what we're trying to go for, I guess. Okay, so making these parts is definitely, it's not that much trickier. It's just a matter of getting kind of the sketch profiles right. So there's just more, there's a little bit more measuring, and what else? We have to make the planes again like we did before.
So with that handle, we're not making the
actually, we
whole
don't.
battery slide thing, right?
With
like how the slightly the diagonal part at the bottom right of the handle
of this, yeah. So these aren't handles. These were just extra parts of the box.
Oh, okay. I thought they were handles.
No, so they're just there because the Robo Rio mounts to here, right? So the two handles are just this top up here. These are these are open so that you can get the wires out of the power diffusion panel down here and run them to the outside. Yeah, that's the intent behind this design. Again, there's definitely some work that has to go into refining this and improving it. So actually, I said we have to make planes for these, but we don't actually have to because we have. We know that this this side mates or is flush up against this piece. So we have an area to sketch on already because this would be the same location as that sketch. So we can sketch on both of those, but we should only have to do it once and then just mirror that part over. It's the same part.
I think in terms of that plate that's going over the PDP, wouldn't it be possible to just have it slide down on top of the plate holders and then you can screw it in, so you can have easier access to the PDP?
Slide down over the plate holders. So is it easier to have this slide down over these side parts and screw it in?
Yeah, I was thinking like you could unscrew it and slide the plate out when you need to, and if you need to put it back on, and vice versa.
Potentially. So the Robo Rio is mounted there. I don't know why it's being weird and not showing things. I hid them all in some weird way. So the part of the idea of these being slightly taller was to protect the Robo Rio. So if it were to ever fall in this direction, the Robo Rio isn't getting crushed by everything. It's landing on these side plates. Where are you thinking it would bolt to? I don't know what I'm missing from your suggestion. It's definitely possible because I think we would like a better way. So, do you have a? There's no like fun drawing options in Discord.
I could like take a screenshot on my iPad and just.
Because yeah, I'm not sure I'm seeing what you mean by
Maybe
come
I'm
down from the
thinking
side and bolt
can
in, but I could
increase
be.
the thickness of the plate that sits on top of the PDP just a little bit, but enough so that you can still slide it into those plate holders and screw it in if it's like a 2-slot joint.
Screw it in from like the sides of these plate holders?
Yes.
Okay.
Maybe
So
that's what I'm thinking.
yeah, so the issue there is the way the T-slot joints basically always have to work for them to be strong is you always have to be able to like slide whichever way the screw goes in, you have to slide the part that you're putting in that direction too for you to get like the locking force, right? Because you can imagine this side plate, right, to come off of either of these two things has to come this direction. And so the bolt has to go in that same, it has to be like in line with the direction like the plate comes on and off because it's what's holding everything together. If you were to like slide this plate down and then bolt in from the side, you're not actually getting any of that strength. Because basically the plate could still slide up and down even if you bolt in from the side. Does that make sense?
Yeah, I think it's it.
Like it would probably be harder because the bolt is trying to squeeze it a little bit, but it's still like if you hit it with a hammer or something, it's gonna just slide off that bolt because you're only kind of holding it with friction. You're not like locking it in with these fingers. That's the whole like advantage of the laser joint. Is the bolt kind of takes away that 1 degree of freedom that is left when you put these two plates together.
Having a hard time putting it into words, but I feel like I have an idea of what I want to do with that.
Yeah, that also, but so keep the idea, and then as you CAD this, CAD the idea. That's kind of the whole point of having multiple versions. Like we can get people's suggestions for improvements. Like that's kind of the whole goal. And also one of the reasons why being able to CAD quickly and kind of understand the ideas is really useful because a lot of times we get that same way on the robot where someone has an idea where they think it's great, but it is tricky to communicate 3D things just in words is not easy. Where if you could just quickly make a sketch and extrude it and do something really fast, you can be like, no, this is what I'm talking about. Like, oh yeah, that makes way more sense. I can see that. Yes.
Yeah, I think whenever we get to that plate holder,